Hi everyone, welcome to lesson 3. Today's lesson is the factor theorem. This is the third lesson in our polynomials unit. So we're going to start off with this opener question just to refresh us from last lesson. So this question says, given this polynomial function is divided by x plus 1, the remainder is 5. What is the remainder when we divide it by x minus 1 instead? So the very first thing I notice here is there's a k value there, so I'll most likely have to figure out k. So let's start us off. So I'm going to go with polynomial p at negative 1, and the negative 1 is coming from here, so we basically isolated this. X plus 1 equals 0 to become x equals negative 1. So p at negative 1 has to equal 5, and how did we get to that 5? We had to use this equation somehow, so I'm going to start subbing in. So I have negative 1 cubed plus k, let's do that in a different color, k of negative 1 squared minus 2 times negative 1 minus 7. There we go. So here I'm going to drop that function off. I don't need it right now. This is going to be negative 1. This is 1. This is going to be just positive k now. So I'm going to write plus k. Here you have two negatives which make a positive, so that's now positive 2 minus 7. Isolating for k, if you move everything away from k, k is now going to equal 11. There we go. So now that we know the equation, we're just going to figure out what's our remainder when x minus 1, if x minus 1 was our divisor. So just down here real quick, if I have x minus 1 equals 0, x is equal to 1. So I'm going to go p at 1. What are we? So we have 1 cubed plus 11 times 1 squared minus 2 times 1 minus 7. And to clean this up, what do we get? We have 1, 11, minus 2, and minus 7. Adding all that up, we're down to just 3. So therefore, we have a remainder of 3. So remainder equals 3 when you add a divisor of x minus 1. So that's just a quick opener. Today's lesson is factor theorem. So this theorem says the following. It says that if p is your polynomial, then if p has a factor of x minus a, if and only if once you sub in that a value into your polynomial, it's equal to 0. This implies two things, and our two stipulations are if your sub in is equal to 0, then x minus a is a factor, and if x minus a is a factor, then once you sub in, it has to equal 0, so they go hand in hand. So let's just figure out if this example here determine if x plus 2 is a factor. So we're looking for 0. Reminder, we're looking for 0 if it is a factor. So what do we need to do? The very first thing I need to do is rewrite my polynomial. So instead of x plus 2, again this is now going to become x equals negative 2. So that's what I'm subbing in. So I'm going with p at negative 2. It's going to be equal to 3. There we go. So I just wrote down the equation, subbing in negative 2 for every single x I see. I'm going to try my best to clean this up. The first term here becomes 48. My next term, that's going to be 8 and 4 make 32, so it's negative 32 in fact. Let's go with negative 32. That's positive 4 and 3 makes negative 12. Of course, two negatives make a positive 6, and you have minus 10 at the end there. If I add up all of these, I get 0 actually. Therefore, you could say something along the lines of x plus 2 is a factor. Is a factor. Perfect. And we're done. In the next example, we're given another polynomial and we're asking if x minus 1 is a factor of this polynomial. Again, the very first thing I'm going to do is flip around this x minus 1 equals 0. X equals positive 1 now because we moved that negative 1 to the other side. So I'm going to plug p at 1 in, and I'm hoping I get 0 for an answer. So here we go. Let's see what we get. Get 3 And there we go. I have my equation all set up. I do want to try to clean it up. So this becomes 3, 4, minus 3, minus 3, minus 10 there. And what does this get us? If you clean it up, we end up with 9, negative 9 actually. So therefore, x minus 1 is not a factor. And again, because we have a number here that's not equal to 0, it's not a factor. So that's how we would run factor theorem. So the next part here is we're going to ask you to use factor theorem to factor polynomials fully. So your steps are here. So what you want to do is factor theorem to find one factor, use synthetic division after that, or long division. I'm opting to use synthetic because it's a bit faster. Continue factoring if possible, and then write your answers with all the factors together. So on this very first example here, let's find out what we got. So it says the possible integral zeros for polynomial. This is what? So basically, again, zeros meaning x-intercepts or roots. It's all the same. All three words are the same. So what I want to do here is instead of testing every number, like instead of testing and seeing when I could get a 0, I'm going to graph this out on my graphing calculator. Okay, and I'm going to quickly type this in as best as I can. Oh, before I graph, make sure that you have proper window settings. So I'm in a 10 by 10 window, by the way. So I got minus 2x cubed. There we go. Minus 8x, and there's my squared right there, plus 3x, and we have that minus 4 at the end. And again, if I have a degree 4 from lesson 1, degree 4 means I could have a possible of 4 x-intercepts. Let's see what happens. There we go. I only have a 2 x-intercept, so my answer should be to 2 x-intercepts. So what is my actual answer? So we go second trace, option 5 there. And just moving our cursor, ooh, I blew by mistake, closer to 1. So here I have an x-intercept of negative 2.32, so it's a nice decimal there. So most likely that's going to end up being a radical somewhere in your answer. So second trace, option 5. Let's see where the other one is. And here we have positive 3.9. So what does that mean? So again, you have two x-intercepts. They're both decimals, so most likely once you factor this, you'll have a radical in your answer somehow, somewhere. Okay. Moving on, factor fully. Here we go. So for example 1 or example 4a, the very first thing I do to factor fully, I'm going to check on my graphing calculator to see if it even crosses our x-axis. That should be our first go-to, is just let's check on our graphing calculator, does it cross the x-axis? If it does, then yes, we could probably factor. If it doesn't, then it probably doesn't really help us. Plus 20x minus 12. So there we go. I have y1 as my polynomial function there, and that's the same one. And y2 is always going to be 0 for me because I am looking to see where I cross on the x-axis. If I hit graph, there we go. I have 1, 2, 3 x-intercepts, and again we had degree 3, so it's a possibility that we have max 3 x-intercepts or 3 roots. I'm going to try to find where they are, so I'm going to move my cursor to the first one where they cross. Hit enter 3 times there. Looks like x equals -1. I'm going to quickly jot that down because that could lead us to an answer. Well, that is one of our answers. So I have off to the side here, x equals 1. I think I might have said -1 in that last one, but x equals 1, definitely there. Second trace, option 5. Let's take a look at where the second one here is. Enter, enter, enter. X equals 2, of course. And what's our third x-intercept? So go second trace, option 5. And I'm just going to move my cursor over. There we go. 1, 2, 3. X equals 6. And the reason why I jotted this down off to the side here is most likely I'm going to try to match up my answer here to the answer off of the calculator. So I'm looking for x equals 1, 2, and 6. So step 1, let's factor this out, and we're going to use f at 1 as one of our examples here to test it out. We're looking for a 0, by the way, just to make sure that it's factorable. So 1 cubed minus 9 times 1 squared plus 20 times 1 minus 12. What does that get us? Let's clean this up. That's 1, that's minus 9, that's positive 20, and minus 12. And if we added all these up, that actually does get us to 0. So therefore, our first factor is going to be x minus 1. And where did I get x minus 1? Well, if I subbed in 1 here to pull it right back out into a factor, I'm just going to go, that's the same thing as saying x equals 1, and then I went x minus 1 equals 0. So I just moved this 1 to the left side. Same side as where your variable is. So if I have x minus 1 is a factor, this is what I'm going to use for synthetic division. So I'm going to set up my synthetic division right below here. There we go. I'm going to use my 1 value right here, and I need all my coefficients. I have 1, negative 9, positive 20, and minus 12. Drop down, multiply, add, multiply, add, and multiply, and add. Nice, and there we go. We want a 0 there. That means we have 0 remainder. So let's write down our factors. Therefore, our factors right now we have is x minus 1, and this ugly equation of, that looks to be x squared minus 9x, or sorry, I'm looking at the wrong row. X squared minus 8x plus 12. There we go. And the second part here is to factor this fully, we're going to ask ourselves, can you factor this here? And the answer is yes. I can simply factor this using any of the factoring from Mathetensi. I'm going to use sum product. So sum product. So things that multiply to and add to. I'm trying to multiply to the number 12, and I'm adding to negative 8. Ooh, sorry, I'm on the wrong side of those. Multiplying to 12 and adding to 8 on this side here. So we're adding to negative 8 because that's my sum side. Sum product side is multiplying to 12. Well, what two numbers would multiply to 12 and add to negative 8? Well, I'm looking probably at negative 2 and negative 6 because they multiply to 12, positive 12 because two negatives make a positive, and they both added together gets you to negative 8. So therefore, our final answer, we have x minus 1, and then we have our two factors. So we have our x minus 2 and x minus 6. And there we go. We have all three factors, and all three will build, once you multiply it all together, will build and get you back to your original function. And of course, if you take a look at the very top here, just to double check our calculator, we had x equals 1, 2, and 6. 1, 2, and 6, and if I scroll back down, here's my 1, there's my 2, and there's my 6.